when we write ratios, we want to be able to write equivalent ratios, and we also want to be able to compare. So writing equivalent and comparing ratios. Okay, first off, we want to be able to write equivalent ratios. So let's say we have two ratios. Let's say one's 5/15, and then we want to write an equivalent ratio with 60 in the denominator. The easiest way to do this is to see how many, well, we want to find common denominators, and in this case 60 could be our common denominator. And we want to see how do we get from a 15 to a 60. Well, 15 does go in evenly to 60. If we have 60 and divide it by 15, we're going to get 4, right? Because 4 times 5 is 20. And then 4 times 1 is 4 plus 2 is 60. So it goes in evenly. So we basically multiply 15 times 4 and we get 60. And remember with fractions, if we want to get equivalent fractions, if we multiply the denominator by a number, we also have to multiply the numerator by the same number. So we're going to multiply the numerator, 5 times 4, and 5 times 4 is 20. And you'll see that if you were to simplify both of these fractions, you'll get the same fraction. So we can say that 20 over 60, 20 to 60 is the same thing as 5 to 15. And like I said, if you were to simplify, 5 over 15, they're both divisible by 5. So we can do 5 divided by 5 and 15 divided by 5. And you get 1 on the top. You'll get 1 over 3. And same thing with 20 over 60, 20 to 60. You can divide both of those by 20. And you'll get 20 divided by 20, which is 1, and 60 divided by 20, which is 3. So both of these ratios equal 1/3. So that means that they're both equivalent. If you used a different one, let's say we start out with 2/3, and we want to find an equivalent ratio with 15 in the denominator. Well, we're going to do the same thing. How do we get from a 3 to a 15? Well, we need to multiply it by 5. So you do the same thing with the numerator. Multiply the 2 by 5, so 2 times 5, and you get 10. So 10/15 is the same thing or equivalent to 2/3. And that's equivalent ratios. That's equivalent. Now let's look at comparing ratios. And we're going to do that by changing the ratios into decimals. And I'm going to draw a line here to separate my work. If I wanted to compare two ratios, let's say I wanted to compare 3/4 and 7/10. Compare 3/4 and 7/10. I want to know which one's greater. So which is greater? Which is a greater ratio, 3/4 or 7/10? The first thing I want to do is change both of those to decimals. And that'll be the easiest way to compare these. So 3/4, which is the same thing as 3 divided by 4. So does 4 go into 3? No, so I have to add a decimal and a 0, and I bring a decimal up to the top. Does 4 go into 30? Well, yes, it does. It goes in 7 times. So 7 times 4 is 28, and I have 30 minus 28, which is 2, and then I can add a 0, and 4 goes into 25 times. So 3/4 equals 75 hundredths, or 0.75. And 7/10, well, that's a pretty easy one. It's going to be 0.7, which is the same thing as 7/10. But if you wanted to divide, you could do 10 divided by, or 7 divided by 10. And 10 doesn't go into 7, so you add a decimal and a 0. And 10 does go into 70 7 times. So 7 times 10 is 70, and then you subtract and you get 0. So there's no remainder. So you get 0.75 or 75 hundredths, and you also get 7 tenths. 7 tenths. So which one's greater? Well, it's going to be 75 hundredths. 0.75 is greater than 0.7. So we can say that 3/4 is greater than 7 tenths. And that's how you compare ratios. First change them to decimals, and then you'll be able to compare them that way.